I'm Khan Siddiqui. I'm the founder and CEO of HOPPR, radiologist and engineer by training. I've been doing this for a long time. So here's we are. HOPPR really wants to help you unleash your data and make AI ML development very easy. Our mission really is to transform healthcare by removing any barrier that exists for either AI development or AI adoption, right? So that's what our mission is, and we're in a broad mission to accelerate AI development for healthcare and beyond. So, the biggest barrier today on AI development really is it's really slow, it's cumbersome to do it, but the bigger problem is it's almost like today is like working in the 80s on DOS computers, right? That's how AI development is happening nowadays. It takes a very long time to get it done. And all you see is point solutions. And the reason it's happening is because a lot of the data is locked and is hard to get to. And then you have to hire 60 radiologists to draw circles on images for any model to properly work. So what we want to do is we really are changing that and make it easy to get data and scale AI development. And we partner with AWS to help us make that happen. How do we do it? We bring in both data sources and consumers of data together. We go in, index all the data that exists in a health system, de-identify it, and put it in a secure sandbox environment where it can be exposed for AI development under HIPAA and privacy and GDPR controls, so you're not losing your data. We provide easy way to create cohorts and governance around those cohort models. So you don't lose your data and don't get lawyers coming after you for giving data to somebody else. And then we make it easy to publish data into productions. So what do you get with HOPPR? You get two services. One is our enterprise data service. This is the one that talks to the VNA and EDW and EHR to pull all the data to do indexing and getting it ready for deployment purposes. And we also generate a proof of evidence based on textual data that exists in an EHR and auto-label the data sets. And once data sets done label, then you have the model development service that makes it very easy and turnkey to build your models and deploy in production. So I'm trying to make it very easy. So we'll do a live demo of this so you can see how this whole thing works. Maybe before we do this, I'll just walk through a little bit of architecture, how we've built this. So first, just talking about data indexing services. So we leverage a lot of AWS tools, such as Comprehend Medical and a few others, on top of our own ontological builders. So we extract textual data from DICOM header information, from reports, from EHR data, bring it into a terminology extraction service, run through ontological model, run through Comprehend Medical, label the data set, store in an EDW, to be able to then expose through Elasticsearch to build your cohorts and do cohort management. Once you've identified your cohort, really how the cohort management happens, the governance for data source to make sure if you're giving access to a third party to build your models on it, you have full control of the data and you're not losing control of the data. And you can disconnect that access to the third party anytime you want to. And once you've identified this cohort, that's when we pull de-identified image data back into a secure sandbox environment for the model to build. And then we have two mechanisms to expose model development, either through AWS SageMaker, so you can just deploy and run all the tools and SageMaker exists to train your model on it. Data is already bound to it, SageMaker is locked down, it can't access anything else except our environment, or there's Kubernetes-based infrastructure to run it other sites also. But that's kind of in a nutshell what our architecture is. And now I'm going to move to a demo. So let's see if it works. So first, let's do a cohort building. So typically what happens is, when you're trying to really build a real cohort, you get a lot of crazy requests. You have to sample size the heterogeneous from different locations, make sure a lot of different things are included, and a lot of crazy things are excluded that you don't want in your data sets. So for example, let's say some of the typical models, let's say you want to try to do a model for lung nodule detection on CT scans. So first thing would be to, let's say, let's see, this is actually running live on one of our customer sites. So it's interesting for me to do this demo because it's live indexing. So each time I run a search, the results I've never seen before. So it's going to be fun to see how it happens. So let's look for CT chest first. So the exam type, we are looking for CT chest and see how much data sets we have from this customer. So 197,000 chest CT data sets that exist. So now we want to make sure that there's no interstitial lung disease. Interstitial lung disease. So now this is where we take advantage of auto-labeling combining Comprehend Medic and on our own NLP work on it. So you want to make sure in the auto labels does not contain interstitial lung disease. Did I spell it wrong? I did. And that it is positive. So any positive case of interstitial lung disease should not be included. If I just search interstitial, so no evidence of emphysema, no evidence for COPD, those also will be included. But here, it's now ontological representation. Anything that represents interstitial lung disease will be excluded from this data set. So let's see what happens. So 197,000, and we go down to 189,000. So 5% cases disappeared that were positive for it. So now let's see, now our real thing that we want to search for is nodule. So same thing, auto label, we want to make sure it contains a nodule and is positive for nodule, so we don't want negative nodule studies. And we go from there, so from 199,000 cases, we have 132,000 positive cases on CT. But to make it even more positive, it'll be good to have comparison that are the same thing, right? So comparison also called positive lung nodule, and there are follow-up studies, then definitely it is much more likely to be a positive case. So let's say we had a comparison of this one. There was a CT done before, and then from 132,000 cases, you have 46,000 positive cases of pulmonary nodule that have comparisons in the past. And does not have interstitial lung disease. So the cohort is ready. It took a few seconds just to build the cohort. And that's the advantage we have. We have such massive data sets across multiple sites that we can narrow down even more and still have big enough data set to do deep learning. So you can actually do, with this type of numbers, do unsupervised learning and get more accuracy than you would do sitting drawing circles on images. So let me walk you through what exactly is happening. So I'll pick up one of the cases here. I hope I haven't seen this before. So, all right. So all the things that we search for are highlighted in the report, and then there's a whole labels come into play. So this patient has 5 comparisons in the past. So obviously, this has to be a positive case. I've been following up again and again for different reasons, labeled for different anatomic entities, and then we also get all the negations from Comprehend Medical, right? So for example, lymphadenopathy was negative, and if you look at the report, where is it? Somewhere in there says no lymphadenopathy. And then also says no obvious osseous lesion. And then we have osseous lesion also as negative in the case. And then there were 3 incidents of pulmonary nodules that turned out positive. So these then becomes the labels for your data sets that we tagged on. And then if you want to verify these images, you can actually launch the image in a web-based viewer to validate whether nodules are or not and see what is going on. So full end-to-end, identify your cohort if you want to validate the stuff, and we can plug into any kind of web-based launcher to launch something to look at it. If you want to plug into EPUB or one of the annotation tools, that could launch too, and you can do those annotations. Those could be saved back into the data set. So we have 46,000 positive cases, and well, obviously you want the normals also, right? So you want negative cases for the other aspect of it, and let's see, and we have 22,000 negative cases. So can you imagine you have now, 68,000 data set in a heartbeat. And then, I forgot to bind it to the notebook. So now let me go back to a positive one first. So I want to attach it to a data set that I want to train on. So these are notebooks that I've created in SageMaker. I'm going to bind it to, I hope this is the right one I'm binding it to. So now what happens is data query request has gone through the PACS. It's going to de-identify data sets and push them into a secure S3 bucket, where it's going to store it and completely secure it. You cannot download this data. It's going to be locked down into our environment. And now I'm going to go back into my notebook interface. I'm going to connect to and launch my notebook. So cohort data that just came in shows up here. And I'm going to launch my notebook. This is a different set because it takes a very long time to move 68,000 data sets. So I'm just showing you. So this is another one that we pull integration with MDAI. So you can put labels from MDAI into our platform also. And you can run a model. I'm not going to run training right now, but you could see your data sets in here and label it. And once you're done, you can hit save the use case in the save and then export it to SageMaker Marketplace also for your production purposes. So literally, completely removing need to understand DICOM, connect to DICOM. if you're proficient in data science and know how to use Jupyter notebooks, you get everything. And as part of the AWS team, you get access to all your favorite tools you want to use, all the sample amazing code that AWS provides to do image classification. Just copy paste it, and you're ready to go. I think I'm going to stop here and open for questions. Yes. Our philosophy is that with that massive data, you can actually do unlabeled, unsupervised learning first, and then go and then validate those labels and reject and approve them. So that's, instead of sitting and wasting time labeling 68,000 data sets, you can run this and then go in bulk, approve and reject it. So we can plug into any of the annotation tools that are out there to bring that in. I'm showing the example of MDAI as annotation to do it, and we can launch that stuff from us, or EPUB from Stanford, and any of the other tools that are out there. We are agnostic to what tool you want to use. Anything else? Yes. So the question was, what's the commercial model? It's a pretty simple model. There's a subscription service to be able to find the data. So it goes from a single user license to enterprise licenses, and then how much you pay for compute, storage, and I/O costs. So it's literally a baseline model to be able to have access to search the data, and then you're paying for just compute, storage, and I/O costs, as if you were paying if you were using AWS natively or something else natively. There's no charge for data itself. Yes, question? You can see every image, you can annotate it, do whatever, you cannot download it. Yeah, so we sign a BA with our source data sources, and we become their service provider that exposes data. And it's all under HIPAA, it's all audit trails, it's all covered under GDPR stuff. So from a developer point of view, you don't see any PHI. And yeah, we make sure you don't have any exposure to any PHI as a developer. But as a hospital, we do sign a BA with them, and we make sure we are cleaning all the data as it's going up. Those can be commercial. It could be researchers doing for research purposes, and they want to deploy it for freely. They can. If there's a company, a lot of our AI companies here are customers. They build this model and deploy in production and commercialize it. So we want to make it easy to do this. We don't want people to be locked down to just data is available publicly or signing up 9 months of legal contracts to get data. We want to make it very easy to do it, and with massive amount of data to make it easy to run. Yes.